Variables are used to store information to be referenced and manipulated by a computer program. Variables provide a way of labeling data with a descriptive name. This makes our programs easily interpretable for us and others reading our code. The primary purpose of variables is to label and store data in memory. The data then can be used throughout your program. Let's create a few variables and assign them values. We'll assign a value, series Sontag, using the assignment operator to a variable that we will name employee_name. We will use double quotes around the name since it is a set of characters. Next, we'll assign the employee ID, AA12345678, to a variable named employee_ID. In this case, we'd also need to use double quotes since the value includes both characters and numbers. Then, assign the value of 125.75 to hourly rate. For numeric values, we do not use double quotes. Next, set the value of true to active employee. And finally, assign 40 to the maximum hours. Each one of these variables references information. Employee name is the full name of the employee. The employee ID is a unique combination of a number and letter value. Rate is the hourly rate in dollars. Active is the status of the employee. And max hours is the maximum number of hours the employee can work. As you can see here, the variables can reference different types of information. That is, our variables can be assigned to values that contain numbers, words, a mix of letters and numbers, Boolean values, and much more. For now, we'll focus on three types of variables: logical, numeric, and character. For example, the variable rate is a numeric value. This should make sense since we only want to assign numbers to rate. While active is a logical data type since it is assigned a Boolean value. Variables can only be of a single type. By default, R sets the type for a variable based on the value that it's assigned. To check the data type of a variable, use the class function. With the class function, we can pass in our variable as the input, and the function will return the data type. For example, class max hours returns numeric. How would we determine the data types for other variables? It's the same process. We simply use the class function. We pass in employee ID to class, and what's returned is the data type character. Now you try determining the data types of other variables: active employee, employee name, and max hours. The beauty of variables is that they can be updated with new values. To update the variable, simply reassign it a new value. For example, we know the variable max hours references the value of 40. We can check by typing max_hours. The value returned is 40. To assign a new value to max hours, just reassign it the new value of 35.5. Changing the data type of a variable. By default, R gives each variable a data type. This is based on the value it is assigned. Just as you can update a variable, you can change its data type. However, the value that it is assigned must be compatible with the type. For example, you can change max_hours to a character by using the as.character function and reassigning the variable to itself. Why would you want to change data types? Well, when you work with data files in R, for an example, an Excel spreadsheet, R may give one of your variables the wrong data type, or you may have a task that requires the variable to be entered of a different type. For instance, let's imagine that R assigned max hours the data type of type character. This is fine as long as we don't want to do mathematical computations on this value. For example, if you wanted to increase the max hours by 10%. So here, we're increasing the hours of max hours by 10%, and when we try to access that value, this will return the following error. Remember, we changed the class of max hours to of type character. So in this case, you'd have to recast the variable to type numeric. We do this by using a function as.numeric, and we pass in the value we want to convert. In our case, this is max hours. You can see here that it's of type numeric now. Let's try again to increase max hours by 10%. Success. Collecting and evaluating user input. Let's take another example. Let's say we want to allow an employee to set his or her own max hours in our system. We'd want to ask the user 2 questions, their name and how many hours they wish to work per week. We would do this by using a readLine function to ask the first question stored in a variable. So in this case, we have a prompt, enter your name, that's passed into the readLine function and assigned to the variable called employee name. This would give the following prompt at the command line, enter your name. Now the user enters his or her name and presses enter. Now let's ask our second question. How many hours are you available to work per week? Here we use the readLine function, our prompt is our question, and then we assign the input or the value to max hours. Let's return some information to the user based on their inputs. We do this using the print function and paste. Oops, you'll notice that we get this error. This should look familiar. What's the problem here? Try to debug it and run the code again.